Hey everyone, I'm here. In today's video, we're talking about a strange invisible gas that keeps our electrical grid running smoothly and safely. We're talking about sulfur hexafluoride, otherwise known as SF₆. This stuff is incredibly useful, but also poses some serious challenges. So let's dive in. First off, let's talk about what makes SF₆ such a game changer in the world of electricity. Now, this compound was first synthesized back in 1901, but it wasn't until the 1960s that its unique properties caught the attention of the electrical engineering community. SF₆ is a really great insulator, and that makes it perfect for use in high-voltage applications. As an electrical insulator, SF₆ is around 3 times better than air at preventing electricity from jumping across gaps in equipment. That might not seem like a huge deal, but believe me, when you're dealing with the kind of high voltages used in power grids, even a tiny slip can cause major problems. Electrical equipment like circuit breakers and switches rely on small gaps between contacts to control and isolate different parts of the grid. When these gaps are filled with SF₆, they can handle much higher voltages without misdirecting current where it's not wanted. This improved reliability is a huge deal for utility companies because it means less downtime and fewer costly repairs. And SF₆ is particularly useful in gas-insulated switchgear, or GIS, which is often used in heavily populated areas where traditional equipment could pose a risk to people and the environment. By using SF₆, the risk of electrical discharge or arcing is significantly reduced, improving the safety and efficiency of power distribution. Additionally, SF₆ is thermally stable at high temperatures, meaning it can handle the heat generated by electrical equipment without degrading, which increases the lifespan of the equipment and reduces maintenance costs. Another cool thing about SF₆ is that it's chemically stable under normal conditions, which means it won't react with other substances, which simplifies the manufacturing process and reduces the risk of equipment failure due to chemical reactions. All of this adds up to a really cost-effective solution for managing high-voltage electricity. Now, let's take a closer look at SF₆'s performance compared to other common insulators like air and various types of oil. First up, air. Like I mentioned before, SF₆ is just plain better at insulating than air is. This is mainly due to SF₆'s unique molecular structure and the fact that it has 6 atoms of fluorine, which is one of the most electronegative elements out there. That means it's really good at holding onto electrons and resisting electrical discharge. Oil, on the other hand, is often used as an insulator in older equipment like circuit breakers. However, it has a lower dielectric strength than SF₆, and it can also be flammable, which obviously creates a fire risk. Some types of oil can handle higher voltages, but they tend to be expensive and require more frequent maintenance. Overall, SF₆'s combination of high performance, safety, and affordability makes it the top choice for many industries. So what exactly goes into making SF₆? The production of SF₆ involves reacting elemental sulfur with fluorine gas in a controlled environment. The reaction is highly exothermic, meaning that it releases a lot of heat. So careful temperature management is needed to prevent explosions. Once the reaction is complete, the resulting SF₆ gas is collected and purified for use in electrical equipment. It's important to note that SF₆ is a synthetic gas, meaning it's not found naturally in the environment. It's entirely produced through human activity. Now let's talk about why SF₆ is such a hot commodity. As I mentioned earlier, SF₆ is incredibly useful for managing high-voltage electricity. In fact, about 80% of the world's high-voltage electrical equipment uses SF₆ as an insulator, and that means there's a lot of demand for this stuff. According to the Electric Power Research Institute, the global market for SF₆ is worth billions of dollars, with China being the largest producer and consumer. The main reason for this high demand is the rapid growth of the electric power industry, especially in developing countries where electricity is becoming more accessible to a wider population. As more people use electricity, the need for efficient and reliable equipment to manage it grows, which drives up the demand for SF₆. Now let's discuss how SF₆ is extracted and processed. The extraction of SF₆ from electrical equipment is a complex process that must be carried out by trained professionals using specialized equipment. The goal is to recover as much of the SF₆ as possible, to reduce waste and minimize environmental impact. First, the equipment is evacuated to remove all the SF₆ gas. Then the equipment is inspected to identify any leaks or damage. Any necessary repairs are made, and the equipment is then refilled with SF₆ gas. Now, processing the SF₆ involves purifying it to remove any impurities that could affect its performance or pose a risk to human health. This is done through a series of filtration and purification steps, including cooling, condensing, and drying. Once the SF₆ is pure, it's bottled or stored in cylinders for use in electrical equipment. So, what's being done to mitigate the risks associated with SF₆? Well, for starters, there are regulations in place to limit the production and consumption of SF₆, and companies are investing in technologies that can capture and destroy SF₆ emissions. One promising technology is the use of activated carbon filters, which can trap SF₆ molecules and prevent them from escaping into the atmosphere. Another approach is the use of electrochemical cells, which can convert SF₆ into less harmful substances like sulfur dioxide. And finally, let's talk about the future of SF₆, as we continue to develop new technologies for managing high-voltage electricity. It's likely that SF₆ will play an important role. However, it's also clear that we need to find ways to reduce its environmental impact. One promising area of research is the development of alternative gases that can replace SF₆ in certain applications. For example, some companies are experimenting with mixtures of nitrogen and carbon dioxide, which have a much lower global warming potential than SF₆. Another approach is to improve the efficiency of SF₆-based equipment, which can reduce the amount of gas that's needed and therefore the potential for leaks. As we move forward, it'll be important to find a balance between the benefits of SF₆ and its potential risks. With careful planning and investment in new technologies, we can harness the power of SF₆ while minimizing its impact on the environment. Well, that's a wrap on our video today. I hope you all enjoyed learning more about SF₆, its uses, benefits, and challenges. If you have any questions or comments, feel free to drop them down below. We'd love to hear from you. And if you like this video, be sure to hit that thumbs up button and subscribe for more videos like this. Thanks for watching, and we'll see you in the next one.
So now, a bit about me. My name is Mike L., and I am an experienced electrical engineer who has worn many hats, holding key roles in projects, engineering, planning, operations, asset management, maintenance, and field resources development. I design and pioneer engineering solutions to propel the utility and energy industry forward. My passion within the industry has also driven me to develop educational materials for the new generation of utility and energy professionals. The knowledge I teach is not only based on my own experience within the power utility industry, but also on knowledge gaps identified by other professionals in the field. Learning from me will provide you with the comprehensive, fundamental knowledge you need to kickstart your professional career in the utility industry. If you are interested in what I have to teach, check out my courses at Udemy and connect with me on LinkedIn, X, and Facebook. Don't forget to comment, like, and subscribe this video. Bye for now.